All right. So last time I talked about how to make stack and queue using single linked list. So I'll talk about the code first. So this is a node which has a next pointer and has a data inside, and the list has a head, tail, and size information. Initialize list has the first it initialize malloc, and then you start with null, head, and size equal to 0. The reason why I didn't put this as a global variable is like in the future, like if you want to make a thread safe environment, like for example, like thread safe, and also you want to make a various type of data structure like L and Q, right? Then you don't want to have a global variable, but also you instantiate it here and then you access it from this list, right? So that's why I initialize it here and then declare it here, and then every single time you increment something, you put it you save it in this L data structure that has a head, tail, and size. And then insert head, and then insert tail and pop. Now today, we're gonna create single linked list. Yeah, I did some tail and print out and stuff like that, and now I'll implement just normal void insert, but this one it has a data and but list L, but this one has an index which you can choose where you wanna put this to, right? Because for example, um, let's create this. Okay, now you have this. Now you wanna put it in the middle. You wanna put this one to be here and then put it here. Then what should I do? The previous value should point to the next one, and this is the first step. The second step, you have to put it like this, right? Then what do I need? I need a previous and then the current. So before you put it in the next this one, I want to make sure this one goes to here and this one goes to this. So this is next, right? And then this is current. So this is how I would do it. First, you need these kind of stuff beforehand, right? If the size is equal to 0, then you need this, right? So how should I make it? So first you have a null case, right? So let's say the index is equal to 0, then if index equal to 0, then what should I do? I can just put this one, right? Then before doing this, I can do like this, then put return here, right? And then also I have to put L here. And then what if index is equal to L of size? Then you want to put in the tail right at the very end. Then you put it like this. Now this is the early return pattern I will use. And then if this is not the case, then I'll malloc it. And then let's say um, if index is greater than L of size, then I'll just do return because it doesn't make sense, right? If this index is greater than the total size, then it doesn't make sense to put at the at here, right? It just doesn't make sense. So then I'll just use early return pattern for edge cases, right? This is the three case I will use, and then if the size is equal to 0, I'll just handle it like this. Right. Okay. Now what I will do is that I'll create node current equal to L head. And what I'll do is uh, while index, I'll do pre-increment. So now what you have to do is current equals to current next. Now from the beginning of the head, the current goes to the number of index it it goes to. So it goes to the n index, the amount of index times, right? And then after that, what I will do is first I have to say that current next is new node, right? Before that, how about next? This one, the new node next equals this one. I made this, right? And then I'll just set this to next as, what is it? Head next, right? And then what should I do? The previous, the not head next, is my bad. Current next, right? And then what this should be? Then this one, current next, is now equals to new node, right? And then I'll have to increase the size plus, right? Now what I can do is print I'll put this as like this, and then 2L, I'll put in the first position, something like look like this. Make sense? Okay, hide, make clean, make main. Now let's check if this is inserted correctly. Just to make sure, I'll use something different value. Yeah, so this goes to first index, right? Let's put this no, this looks 1. Doesn't make clean, make main. So when I put it on the very first, it goes to the end. Let's put it in 2. Make clean, make main. Now it goes to the after second index. Right, then let's try to do this. Let's put this 4. Make clean, make main. So as you see, this is being printed at third one. After the second one, it looks right, right? Then I put 1 here. Make clean, make main. So now it goes here, and then if I put 0 here, make clean, make main. Now it goes to 3. Now the edge case, if I put this 3, main. Yeah, it goes after the third index. So this is what it is. Technically speaking, you can just do else at -1, right? I think this should be correct. Make clean, make main. Not -1. Oh, size starts from 0. So yeah, this is right. make clean. Yeah. Yeah, this is correct. This is more than correct. If it's greater, my bad. It should be like this. Terminal, make clean, make main. Yeah, it should be like this. This code is correct. And then after that, what should I do? Now you gotta delete the node, right? How should I delete the node? So this one, it has the pop, right? So what you can do is delete node, list pointer L, and then int data. Um, if data equals to list head of data, this means you have to just pop it, right? Pop.l. Let's say, um, yeah. And even after this, um, if data equals to L, and even after that, it still equals to this thing, then what you can do is you do recursion L data. Why is this? Because let's say if I first pop this and even after that it's still equal to this, I call this again. That's why. So I do recursion type of work, right? Yeah, this will work for sure. Yeah. And then after that, if let's say if this is not the case, then while current is not equal to null. How would I delete the node in the middle? Let's say if I have stuff like this and then I would like to delete this. First, I have to shift this part to here. Which data has this? This. Let's say this is current, and let's say this is a P node. P node will identify this part as this one. So how I will do it is that I only have to just check what this one is lying to and then change it to the previous value of this. In order to go, since this is not double linked list, how I would do is that first current equal to L head node pointer. This makes sense, and then current equals to current dot next. And then how I will do it is that if you find it, current data equals to data, then you need to delete it, right? And other than that is good. But what I also need is node pointer equals p node. I need a p node beforehand, right? What I'll do is p node equals to current. Then if I find the data, what I need to delete, what should I do? I have to check I have to change what the current next was pointing to and then changing to here, right? So how should I do it? P node next equals to current next, right? And then that's all, right? And then I have to also decrement the size by minus minus. And also I need to delete the current, right? How would I do this? Is because I'll make a node pointer temp D node equals to current. And then I'll free D node. But what's the problem here? The current, if I'm going to delete, let's say, where did the pen go? If I delete this, then current will be gone. Let's say I want to delete this too. Then what I should do is I should update the current to be P node, right? So what I would do is that before changing this, I'll update current equal to P node. And I think this will do it. I also forgot to delete this one, right? And then let's say I'll create pop back. I'll change this to tail, right? But now what I need to change is the if the tail node is the one that needs to be deleted, then I'll probably need to use a while loop to loop forward because I need to know the previous of the tail, but I don't technically know the previous of tail with using linked list. So instead of just making this, I don't think I need this. I'll just cover it from here to make sure that it deletes from here, and then I think this does it, and then let's see if this works well. Now what I'll do is delete node. Let's try to delete this first, and then see if this is working well. This is the first case. Make clean, make main. Sec fault. Okay. Now, what's the mistake? Oh, it starts from here, that's why. My bad. It starts from here, and then this is the code, make clean, make main. So now I got a sec fault. Why is it? Because I got an error. Let's see if this works first. Make clean, make main. Sec fault, okay. So let's first try to print this one first. Make clean, make main. Okay, this one works. But now if I do make clean, make main, and then if I try to delete this one in the middle, make main. This is where it costs. I think it's probably because of this part, dnode and current. I made this equal to pnode. That's why. what I can do is, yeah, because the P node goes to current node, then what I can do is, no, next. I can do something like this, right? Let's see if this works. Now it's being having a sec fault. I'm guessing this is the wrong value. 4, and then I'm supposed to delete this, but now it generated a sec fault. It gave a trashed value, the wrong value. What I can do is I can technically start from the beginning. So what I can do is L head. I can start from the beginning again, and then I'll loop through again. Make clean, make main. It's not equal to null. I changed p node equals to current. Then if current data equals to data, let's try to delete something that is not can be found. For example, 5. Let's see if the looping part is working well. It is working well. So it did loop through, but the problem was this part. If I found the data, the D node is the current one that I'm supposed to delete. And I set the P node next, the previous node, P node next equals to current next. Yes, that's right. Okay. And I set this to current equals to current next, which technically speaking, this should be okay. Because I'm updating this, but after that, I'm updating again. And that's the problem. All I can do is P node. But as you know, as we saw, this shown an error, right? Make void. Make clean make. Okay. Let me see how I did it previously. Oh, I think I should supposed to put it here. Okay, it's deleting correctly. Right, so before P node was updating too early. That's why I have to make sure current is here, because before updating current next, I save this here and then I make sure that P node is previous. So this was my bad. I put in the beginning. Now it's working well, right? Let's duplicate it now. Make sure it's deleting 2. It deletes everything, right? Now, let's try to delete 10, but now with a new edge case, like this. And then I also make sure at the very edge is also deleting correctly. Make clean, make, main. See, as you see, it's deleting a whole node, which is everything that's 2 that is deleting. Because it's only printing 10, 10, right? Now let's try to delete 10. Make clean, make, main. It's deleting all the stuff, right? Only 2 survived, and every 10 deleted. Now, I tested our edge case. Now this was a single linked list. Thank you.